Hi, I'm Z. I work at Tigris Data, and I'm going to talk about the concept of nomadic infrastructure design for your AI workloads. But disclaimer, this is not a product demo. This is thought leadership, which is a kind of product, I guess. So at a high level, any workload, I don't know what to call computer programs anymore. Do I call them containers? Do I call them deployments, services? Everything's overloaded. Workload, something, running somewhere with something, doing something. Okay? A workload has three basic parts: compute, network, and storage. Compute is the part that does the number crunching or the linear algebra. The network is what connects all our computers together. It's why we have to update everything every fifth femtosecond. And storage is what remembers things for next time. This is what you're built on over time. As I've been messing with new providers and trying to find cheap hacks to get my AI stuff working at absurdly low prices, I found a really weird thing. Compute time is cheaper than storage time. I don't know why this is the case, but with like Vast.ai, RunPod, all these places, spending time downloading things is cheaper than storing them for the next run. Like, look at this. I selected a 4090 in South Carolina at random. It costs 2 pennies per hour, which you probably can't see that well because I could only make it so big before it would start to look like, cursed JPEG abominations. But 2 pennies per hour with 50 gigs of local storage. But keeping that data around is 1 penny per hour. That's half the price of the instance doing nothing. Like, sure, there's probably some creative financial decisions that go on into pricing things like this, but either way, if it takes 30 seconds to boot it and it costs like 2 cents an hour, then it actually costs more to store things than to not store things. Really weird thing to think about. So let's learn how to cheat at infrastructure design and find out why I am not allowed to be an SRE anymore. Asterisk. So the first thing that you can do is scale to 0, because people don't use workloads when they're asleep. This is a graph. This graph has a sinusoidal wave, and it's from Blue Sky when they blew up late last year. And you can see that there's a sinusoidal wave where there's a peak in the middle of American daytime, and then it all goes down to very low. If you've ever worked in SRE stuff, you see this all the time. This is what your request rate looks like. This is what your active user count looks like. This is what everything looks like, because this is how people are awake and go to sleep. So if you just make your service turn off when nobody's using it, you already save 12 hours of time per day. Remember, it may not be your money, but money is expensive now. The free tier is going to end. At some point, the hype will die out, and the price of compute will reflect the price of acquiring the hardware. Your AI workloads are dependencies, and they are black box dependencies. Without those workloads, your product is doomed. Those who control the infrastructure spice control the infrastructure universe, or whatever Frank Herbert said. So when you're cheating, it's all about making trade-offs. There are several factors that come into mind, but in my view, the biggest one is time, because that's what you're built on. Specifically, cold start time, or the time that it takes to go from the service not running to the service running. Here's an example of all of the steps involved in running a workload on some cloud provider somewhere. Statistically, Docker is the universal package format of the internet. It's going to be in a Docker image. That has to be pulled. NVIDIA stuff is like gigabytes of random C++ libraries and a whole bunch of bytecode for GPUs that you don't have, but has to ship around anyway because who knows, you might run it on a 2060. That gets pulled, extracted, it gets started. Your app boots up, realizes, oh, I don't have any models. I need to pull them down. And then that time that it takes from pulling the models to loading the models is time where you're on the clock doing nothing useful. But once you get to the point where the models are loaded, you can inference them, do whatever it is, and somehow make profit. But everything above that inference model step is effectively wasted time. Depending on the runtime you're using, this can cost you money doing nothing. How can we make it fast? How can we give our infrastructure SANIC speed? Users don't care if you're trying to cheap out. They care about responsiveness. There's 2 ways to handle this, and both are different ways of cheating. One of the biggest ways to cheat is to make your workloads happen on a regular basis where you can do a whole bunch of stuff en masse. This is called batch operations. This is how the US financial system works. This is a horrifying thing. You bundle everything up into big batches and do them every 6, 12, 24 hours, whatever Father Time says you should do. This is great. Like, let's say you have a wallpaper of the day app and you want to have every wallpaper generated by AI for some reason. Statistically, if there's the wallpaper of the day, you don't need to run it more than once a day. So you can just have a cron job start it up, generate the wallpaper, put it into storage somewhere, mark it as ready for the world after it passes some no boobs filter, and Bob's your uncle, you're good. This lets you run the most expensive part of your app on pennies for the dollar using the model that you want, that you have the bytes for, so that you can't have your upstream infrastructure provider say, oh, we're going to turn off, image to Florb or whatever, and good luck migrating to something else, buddy. But the other way to cheat is to speed up the cold start process. Let's look at that list again. Pulling models is the slowest part because that's usually done by your Python program, and Python is still single-threaded in Anno Dominium 2025. I almost said 2024. Your app has to sit there doing nothing, waiting for the models to pull and get ready. This can take minutes if you're unlucky and take tens of minutes if you're really unlucky. What if you could cheat by doing it in a phase where you're not build? You could just put it into the Docker image with the runtime, right? So I did this, and to my horror, it worked kind of well. There's just many problems. Number one, Docker hates this. Docker absolutely despises this because the way that Docker works is that it's a bunch of tar balls in a trench coat, right? And in order to pull a Docker image, you have to extract all the tar balls, and it can only extract one of the tar balls at once because, tar balls are weird. And if you have a Flux dev, that's a 12 billion parameter model. So we're talking about 26 gigabytes of floating point numbers, including the model, the autoencoder, and whatever else it has. I don't remember. But this isn't time you have to pay for, but it is time that users may notice. But we're cheating, so you could just do it for batch operations, I guess. I don't know. If you want to do this anyways, here's a trick I learned. Model weights don't change often. So what you can do is you can make a separate Docker image that has all of the model weights and then link those model weights into your runtime image. This works. I'm horrified. You get to reuse these models between that because if you have a bunch of things a Stable Diffusion 1.5 checkpoint and each LoRa in a separate layer, you can just have those be there. And if you need to download a separate LoRa, you can do that at runtime and only have to download 150 megs instead of 5 gigs. That's a lot faster. And you can also reuse them between projects or workloads, which might be preferable depending on what you're doing. If you have a base model like Llama 2 and a whole bunch of LoRa's for inference, yeah. Other big problem when you're doing this, the Docker Hub will not allow this. It has a maximum layer size of 10 gigabytes, or a maximum image size of 10 gigabytes. And my test thing that uses Stable Diffusion 1.5, a checkpoint from 2023, it's an 11 gigabyte image. GitHub's container registry barely tolerated it. I had to use my own registry. It's not that hard. Registries are basically asset flipping S3. And I work for a company that is basically S3. So this is easy to do, and I can tell you how to do it after the talk. I have stickers. But the biggest upside of doing this horrific, horrific crime is that your one deploy artifact has both your application code and your weights. This is something that doesn't sound like a big advantage until you've had your model get pulled from Hugging Face or Civitai or something, and then you have a production incident that you can't easily resolve because nobody has the model cached. Ask me how I know. And because there's just one of them, you don't have multiple artifacts to wrangle. You don't have to have extra logic to download weights. It's amazing how much code you don't have to write when you don't have to write it. But this is the key idea in a nomadic compute setup. Your workload ships with everything it needs so that it can start up quickly, head out to hunt whatever deals it can, get the job done, and then head back to the cave to slumber or something. The metaphor fell apart. I'm sorry. You also don't need to be beholden to any cloud provider, because if you can execute AMD 64 bytecode and you have an NVIDIA GPU and there's a modern-ish version of CUDA, it doesn't matter. Everything else is fungible. The only way that you'd really be locked in is if you're using local storage. And remember, we're trying to save money, so we're not. So you can just use tools like SkyPilot or that one thing, I forget what it's called, but it allows you to punch in all of your accounts that you have startup credits with, and it'll just distribute the compute between all the different clouds so that you can really be cheap. It just works. Asterisk. Okay, so let's tempt God. So, I have to move this up here. I am very good at web design, so this is an HTML 1.0 form. So my demo is a button on a page, and if you click the button, you get anime women. Is my laptop on Wi-Fi, hon? Oh, there we go. See, that was hallucinated by a GPU that I spun up earlier and just have been having a script run the health check URL over and over and over so it doesn't think it's idle and terminate itself. I'm glad that worked. It's only supposed to be one of them, though, so I guess that's just Stable Diffusion 1.5, eh? But yeah, special thanks to all these people. You know what you did if you're on this list. You know what you didn't if you're not. And with that, I've been Z. If you have any questions, please ask. I don't bite hard. Stay warm. Any questions? Yes. Oh.
So obviously the gain here is because we're saving costs because it's running on serverless compute.
Yeah.
Someone else is paying for the Docker pull time.
Yeah.
And that's not us, so we're smiling.
Yeah.
Okay, love it. 10 out of 10.
This, I have only tested the pricing model via Vast.ai, and the exact workflow I'm using does require 6 gigabytes of VRAM. So I set it to a fairly high amount of VRAM just so that I get a statistically faster internet connection to make the cold start time faster, because I was able to get it down to 4 minutes to pull the image and do things, but if I did it for this demo, I'd have to start okay, here's the demo, and now while that's going, here's why this is a crime. I didn't feel like doing that. Yeah?
It seems like a pretty good idea to keep all your dependencies where you have them instead of relying on fetching them when the thing starts up. And then having your own container registry isn't the end of the world, it seems.
Yeah.
So if it's a big image to pull, then that can be a problem. But if you want to scale up from 1 to 2 instead of from 0 to 1, then do you know if there's caching so that it's a faster pull for those providers?
The question was, is there a way to do 0 to 1 is expensive? Is there a way to make 1 to 2 less expensive? And the answer to that is it depends. The exact architecture I'm using puts everything into Tigris, which is kind of like S3 in a CDN. So it'll pull the images from the closest regional Tigris region. Regional Tigris region. I am good at words. So that is kind of like a cache, but it really depends on where your nodes are, where your infrastructure is. But in my experience, it's been fast enough that I haven't had to care. But it's going to take, depending on the biggest time that it's going to take is the single-threaded extraction process. And trust me, I have looked for ways to speed this up, but I'm not omniscient yet. Yes?
So your main complaint was toward Python, but what about using another multi-threaded language to download the files? I mean, at the end, you just need the files to be in the directory and then run the Python script to load it.
The question was, Python is single-threaded. What about using other languages? I could do that, but I could also not do that. Like the main reason why you wouldn't want to do that is having multiple languages build tooling involved in a single build already makes things bad enough. But when you mix in AI stuff and the AI stuff barely works on a good day, it's not something that I wanted. It's not a risk that I wanted to take for this demo. I'm pretty sure you could have like a Go program that would just like be able to actually be parallel and do real multi-part downloading and like rip it to shreds. But I don't know.
So is it the Docker image extraction or like pulling process that's also a bottleneck for the single threading?
The question was about the Docker, like what's the bottleneck in the Docker load process. There's 3 phases to loading a Docker image. There's downloading the layers, there's extracting the there's selecting which layers you need to download, there's downloading the layers, and then there's extracting the layers. The first 2 are the things that I have control over. But because I'm using serverless infrastructure, I do not have control over that last one, other than the IOPS and the IOPS of the SSD on the random